Here are 4 situations where the danger of root resorption is pretty much zero: extrusion, intrusion, rotation around the long axis of the root, and tipping around the apex of the root. Except in the last situation, the tooth does not tip, thus avoiding excessive resisting forces in the apex of the root. In the case of tipping around the apex of the root, it is true that there is no damaging resisting forces to worry about, but this phenomenon is only transitory and therefore of no consequence to the treatment of the patient. For this reason, in the future, we will only talk about the extrusion, intrusion, and rotation as being types of safe tooth movement. In all other orthodontic situations, we need to use a combination of linear and torque forces, which we call companion forces, to move the teeth in translation as much as possible. This is how to move the teeth faster without root resorption. In this lesson, we will look more in detail at root resorption, its ubiquitous nature, its causes, and how orthodontists have traditionally tried to remedy it. Then you will learn how, with a broad range of forces used in OrthoExpress, you can much more effectively conquer root resorption and reduce your treatment times. Root resorption is a harm that we as orthodontists seek to avoid at all cost, but we will probably never be able to avoid root resorption completely. Teeth with excessive root resorption are damaged teeth. We seek to straighten teeth, not to damage them. As orthodontists, we will always walk a fine line between getting treatment done in a reasonable amount of time and treating the patient so fast that there is excessive resorption of the roots of the teeth. Root resorption is a major limiting factor in treating any orthodontic patient. Prevailing wisdom says that slowing down the orthodontic treatment by using lighter wires and forces will result in less root resorption. And to a degree, this has been proven to be true. Using lighter forces has resulted in reduced root resorption, but it has at the same time produced lengthened treatment times along with other negative consequences. You're about to learn how I, with OrthoExpress technique, treat my patients with even less root resorption than the average in the profession, 50% less. Even while doing that, I treat my patients 40% faster than the average in the profession. The key to achieving decreased root resorption along with decreased treatment time is the broad range of forces that OrthoExpress technique provides. Within this range of force are light forces and heavy forces. Light forces are applied during certain stages of the orthodontic treatment, and heavy forces, up to 5 times stronger, are applied during other stages. Because of the need for heavy force and large arch wires, I use a 22 by 28 thousandths brackets. You can always put a small arch wire in a large bracket, but you can't put a large arch wire in a small bracket. As you progress through these OrthoExpress lessons, you will not just learn when to apply light forces and when to apply heavy forces. You will also learn how to apply a strong combination of forces called companion forces during the proper treatment phases to speed up your orthodontic treatment and still keep root resorption in your practice at a minimum. This double benefit will go a long way toward helping you to enjoy the increased income and happier patients. Skillfully using companion forces is what has revolutionized my practice. It can revolutionize yours as well. In this lesson 1, you will begin learning how to apply companion forces to your orthodontic treatment. When you have fully understood and have mastered the correct application of companion forces, I will teach you numerous ways to apply them to better treatment of your patients. I expect that OrthoExpress will be just the beginning of a change in orthodontic treatment that will revolutionize orthodontics in years to come. In developing your skills in applying companion forces, you need to remember 2 T words: tipping and translation. Tipping refers to the tooth's penchant to pivot around a center of rotation in the root of the tooth when a force is applied at its crown. Translation refers to moving the teeth without tipping. In the OrthoExpress technique, tipping is where we have to be very careful because of its sinister contribution to root resorption. And translation is what we seek to achieve because it dramatically contributes to the reduction in root resorption and allows us to speed up the treatment. Our continual goal is to minimize tipping, knowing that tipping will always be a major issue in any orthodontic treatment. We can never be rid of it completely. So what do? We learn what limits we can work within and maximize the treatment within those limits. The threshold of root resorption is the limit that we have to work within. The threshold of root resorption is the force at the apex of the root below which we can move teeth without causing root resorption. We will learn to maximize the treatment of the patients by knowing when and where the threshold of root resorption is and working just under that threshold during the whole treatment. We will learn how to use the translation of some teeth to protect the tipping of other teeth. We will learn how to use every aspect of the treatment to our advantage. This is OrthoExpress. So in simple terms, uncontrolled tipping is bad and translation is generally good. That said, there is no way to completely eliminate tipping. Root resorption, when the teeth are tipping, can be controlled by the use of very low forces at the bracket. You will also learn techniques that will move teeth with as little tipping as possible. Knowing how to use companion forces will help you to move teeth with less tipping and more translation. Knowing this will help to speed up the treatment and reduce root resorption in your orthodontic practice. I showed you with my OrthoExpress modeling program how a tooth acts like a lever. When a force is applied to the crown, the tooth tips around a center of rotation near the middle of the root. The crown moves in one direction and the apex of the root moves in the opposite direction. It doesn't matter what direction the crown is pushed or pulled, the reaction in the root is the same. Now let's go back to our OrthoExpress modeling program to deepen our understanding of tipping and translation, the two T words, and their relationship to speeding up the treatment and reduction of root resorption. We're going to be using the OrthoExpress modeling program to demonstrate some of these principles that we've been talking about. To understand this relationship, one must first understand two important types of forces: applied forces and resisting forces. Applied forces, either linear, torquing, or combination, are those forces that the arch wire applies to the crown of the tooth at the bracket. Resisting forces are those forces in the root of the tooth that resist the force applied at the crown. Most of the time we will be talking about resisting forces as they occur at the apex of the root because the apex is the most vulnerable area of the root. Managing these forces at the vulnerable apex to reduce the risk of root resorption is one of our most important goals in OrthoExpress. Now I am about to show you how the application of two forces, a linear force and a torquing force, can effectively move the center of rotation outside of the area of the tooth and spread the resisting forces over the length of the root, sparing the root apex. Do you remember what we called a good combination of linear and torque forces? You got it. Companion forces. So how exactly do these companion forces, linear and torque, work in concert to move the teeth in translation? Now I'm going to go to my computer modeling program and show you what I mean. Now what I'm going to show you is how a linear force moves the crown of the tooth, and this happens to be an upper central incisor. We're moving the crown of the tooth lingually. The tooth tips around a point in the middle of the root at the center of rotation, and the root moves in the opposite direction to the crown. Now I'm going to show you in this one how a linear force causes excessive resisting force at the tip of the root, and then we'll show you how a torquing force causes excess force at the tip of the root in the opposite direction, and then we'll show you how we put them together as companion forces to reduce the force at the tip of the root and move the tooth faster. So first we have a linear force here. We have 15 grams of force on that tooth. The tooth is tipping around a center of rotation here. The crown is moving lingually, and the root is moving labially. You watch down here, down below here, and there'll be some numbers that come up when I put my cursor up on the root of the tooth. We have a 0.76 grams per square millimeter at the alveolar crest, and you notice that there are red lines here. That's where the excess pressure is. The lines diminish as we move up the root of the tooth to the center of rotation. The amount of resisting force at the center of rotation is essentially zero. Then these lines on the edge of the root increase until there are red lines at the apex of the tooth, and the apex of the tooth is moving labially in the opposite direction of the crown. Now, as this force increases at the apex, this is where we get root resorption. So tipping is a very bad thing in orthodontics if you're not controlling the force on the crown of the tooth properly. Now I want to go to a torquing force where the crown of the tooth moves labially and the root moves lingually in the opposite direction to what we just looked at. Now we have a pure torquing force on the crown of this tooth. This is the same central incisor, and we have a pure torquing force represented by this curved arrow here. Now if you watch down below here again, if I put my cursor up on the root of the tooth, at the alveolar crest we now have approximately 0.6 grams per square millimeter of resisting force. As we move up the root of the tooth and we reach the center of rotation, there's almost 0 grams per square millimeter. And as we move on up, the resisting force increases as we approach the apex of the tooth. Now this is where you get a lot of damage to the tip of the root. In other words, it's this excess force at the tip of the root that causes root resorption that we need to be very careful about. With this amount of torque, the resisting force at the apex of the root is 0.9 grams per square millimeter. Now we're going to look at the two forces added together. We have the linear force of 15 grams per force at the crown of the tooth or the bracket. We also have the torquing force of 18 grams centimeters of torquing force at the bracket. And now look what happens. The pressure on the edge of the root of the tooth is the same all the way up the side of the root. In other words, if you watch down here again, we have spread out the resisting force on the root so that we only have 0.15 grams of resisting force, and it stays about the same all the way up to the apex of the tooth. Now, in my experience, I think the root resorption threshold is somewhere between 1 and 2 grams of resisting force at the apex of the tooth. So I'm going to increase the forces on here and show you that we'll still stay under the original resisting force of 0.7 grams per square millimeter, even though we increase the force and increase the torque and keep the tooth moving in translation. Now I've increased the linear force at the crown of the tooth 5 times what we had before. We had 15 grams, now I've gone to 75 grams of force at the crown of the tooth. And I increased the torque from 18 gram centimeters to 89 gram centimeters of torque, represented by this curved arrow and this linear arrow right here. Now these two forces again are companion forces. They have spread the resisting force on the root evenly all the way up the root. Now when a tooth translates, you notice the center of rotation is not in the area of the root. This says up here in this red box that the center of rotation is 423 millimeters away from the apex of the tooth. Now when we put these two forces on here, again we have companion forces. And if you watch down below and see what the resisting force is. At the alveolar crest, we have 0.789 grams per square millimeter. Remember, it was 0.7 grams if we tipped the tooth with only 15 grams of force. Now we have 0.7 grams all the way up to the apex of the root. And we have actually what we've done, we've increased the force at the crown, the companion forces at the crown, we've increased them 5 times, and we have not increased the amount of resisting force at the apex of the tooth where we get the damage when we tip the teeth. When a tooth is translating, the force at the crown of the tooth can be 5 times as much as it is when a tooth is rotating around a center of rotation in the middle of the root. In other words, when a tooth is tipping and there's only a linear force. Now, as you can see, this OrthoExpress modeling program has demonstrated some things that give you a different look at the dynamics of what's happening in the root of the tooth. By using this program, it will help you to understand a lot of what we are talking about in the OrthoExpress lessons. This is where I learned what to do to keep teeth from being damaged by root resorption, and it will be a big help for you to understand how to treat your patients in the future. Now we are going to go to the Beacon program to show you a patient and how to apply some of these principles. Earlier, I showed how excessive force per unit area at the apex of the root is a likely cause of root resorption. The term force per unit area is a concept that we really need to understand in our quest for understanding and reducing root resorption. Since a tooth is encased in a bony structure, any force applied at the crown of the tooth can cause damaging forces at the root. The possible exception to the rule would be in cases of intrusion, extrusion, and rotation around the long axis of the root. As we learned before, with these 3 common types of tooth movement, the apex of the root is safe. I believe you are beginning to see now that it isn't so much the strength of the forces at the bracket that determines whether or not a tooth can be moved safely. Rather, it is in the way which the forces are applied to the crown that can keep the apex of the root safe. In fact, companion forces can lower resisting forces at the apex of the root by 80%. OrthoExpress uses this fact to speed up orthodontic treatment, and this is what these lessons are all about. Now, before moving on to the most important part of the lesson, I want to pause for a minute to make one thing very clear. The OrthoExpress technique cannot consistently achieve pure translation when moving teeth, but we can consistently achieve near translation. Moving teeth in near translation, as we have seen demonstrated in the modeling program, moves the center of rotation outside of the root, and with the center of rotation outside of the area of the root, we get most of the benefit of pure translation. So now we come to the crux of this lesson, knowing when to be very careful with the forces applied at the bracket, and when and how the forces on the teeth can be increased dramatically without causing further damage to the apex of the root. In other words, we will learn how to keep the force per unit area at the apex of the root below the root resorption threshold. We will do this and still move the treatment along as fast as possible. One of the basic principles of OrthoExpress technique is the judicious application of much stronger forces to speed up the treatment. But you must also know that in certain phases of OrthoExpress technique, we use very light forces, even lighter than those advocated in mainline orthodontics. Underlying all of our decisions of when to apply heavy or light forces is the reduction of root resorption and the protection of our patients. We will be talking more about how to effectively and quickly move groups of teeth in another lesson.